Alright, hey, today we're going to be working on graphing polynomials. So here's a polynomial, and the first thing we look at looking at the polynomials, we look at the solutions, which are right here, the x pluses and the x minuses inside those parentheses. So the first one, and you also have to look at the powers, but we'll get to that, x plus 4. So you have to make both of these expressions equal to 0. Whatever are inside the parentheses, and then you have to solve for them. So x plus 4, you get x plus 4 equals 0, x minus 1 equals 0, and then you get x equals negative 4 and 1, right? Those are the two x's. So now here in the graph, okay, this is 0. So now we got to go find negative 4. So that's 1, 2, 3, and 4. There's our first x-intercept. These are x-intercepts. Now we look at 1. Go back to the center. 1. So now we got both of these. And then now we look at the beginning sign. Is it negative or positive? Well, since it's looking at the negative, it's a negative sign. So that means this whole equation is going to be negative. The next thing we have to look at is the degree of the polynomial. So to find that, we got to look. What is the degree? And the degree is just adding up all of the exponents of the equation. So you see the exponent here is 3. And then you see the exponent here is 2. So they add up 3 plus 2 equals 5. So the degree of the polynomial is 5. So now, with that, we know it's an odd degree. So that means, you see, a polynomial could either be this or something like that. I mean, there are other forms, but this is what we want to keep it to for now. The evens look like this. The odds look like this. So now we know the degree is odd. It looks like this. This is a positive odd. However, since it's negative, it flips. So now it becomes that. So it comes down from negative infinity and goes to positive infinity. That's the range. Not the range, I mean the domain. But yeah, so now we know it comes from the top here at some point and it goes through this point. So let's start here, start off. So, but now we look at the powers. So now it says x plus 4 squared. So since this power is squared, whenever something is squared in a polynomial, when you graph that, that means it's going to bounce off that point. So over here, it's going to bounce. It's just barely going to touch that point, and then it's going to bounce right back up. And then it goes up, and then we look at our second point where it has to cross through. Now, here it says it's to the third power. Whenever something is to the third power, it squiggles just like here. And just as you notice, when it's the second power, it bounces like that on the point. And then it squiggles right through the point if it's a power of 3. So over here, it goes up, however, this is just a relative graph. And then it like squiggles through. You see that little squiggle right there? It squiggles through. And then it just keeps on going down and down. And there's your graph. On a big scale, it's just one of these big squiggly things. Except it bounces up, and then goes down. With a little squiggle right there. Maybe if I draw that a little bit better. But yeah, that's how you graph this polynomial. The coefficient there, I mean, you don't really have to graph it. This is all just a relative. That's what you want to do. I almost forgot one thing, and that's that you always have to look at the y-intercept too. So y-intercepts, you just plug 0 in for x. I mean, from here, you get 0 plus 4, and then you get 4 squared, and then 4 squared is 16. And then you get 0 minus 1 is negative 1 to the third, which is just negative 1. And then you get the negative 3 at the front. So this is your y-intercept, which you get negative 16 times negative 3. And then here becomes positive 48. So 0, 48 is your y-intercept. And of course, 0.48 is nowhere on here, but just make sure to label, you know, wherever it touches y, 0.48, even though that's definitely not 0.48. 0.48 is all the way up there. So make sure you just mark that. And, well, that's really it. That's how you graph a polynomial. And I'll come up with the next example. Here's the next example, so let's get right into it. These are x-intercepts, x minus 1, x plus 3. So now we set them equal to 0. Now we get x equals 3 and negative 1. So now let's find 3 and negative 1. So negative 1 right here, since that's the center. And then now we got 3. 1, 2, 3. So now with that, we look at what's the degree. 3 plus 2 is 5. So the degree of this polynomial is 5. It's still odd. So in this case, now remember, if the degree is even, it would look like that. If it was odd, it looks like a squiggle. So since it's odd, let's do the squiggle. So since it's a positive now, you don't have to flip it. So it comes down from over here, wherever, and then now it has to cross through negative 1. But what is the power of it? Well, before we went through, the power is even, so it bounces right over. So, or it's 2, so it bounces right over. So it bounces, goes down, and then we have to look at the y-intercept. What is the y-intercept? Because it's crossing y right there. Well, we just plug in 0 for x. So 0, negative 3 to the third is negative 27. 0 plus 1 is 1 squared. So it's just times 1. And then times 4. And then 4 times negative 27 is, let's see, 80 and then 28. About 108. So since our now y-intercept is 0, negative 108, I mean, this is nowhere near that. So over here, I mean, we can just make like a relative point and say that's 0, negative 108, just trying to say that that's our y-intercept. And so anyways, it hits the y-intercept. And you see here, we have to get to this point. So of course, it's going to go back up. However, that's x minus 3, which is 3. And you see the power here is odd. So it's going to squiggle right through it. So it's going to squiggle. Kind of, I'm not really that good at squiggling. Now it's just going to go up. And boom, there is, let me just write out the exponents for you. Take 1, 0, 3, 0. So this is how you solve a polynomial. I mean, not solving, but you're basically graphing it. And yeah, you just look at the exponents, you look at the coefficient, the leading, more so the leading term is in negative or positive, and you look at, of course, the x's, and you try to find out what the x-intercepts are, and you graph. Easy, right?